In this video, I'm going to go over some tips on how to solve subnetting questions. When students do the subnetting lesson, they're kind of shocked when they see the subnetting questions because they don't really resemble what they've learned in the lesson. In the lesson, we go through how to do subnetting, how to create the subnet addresses, how to create the range of usable IP addresses, and how to create the broadcast addresses. But when they look at a subnetting question, the subnetting questions often are asking about one specific subnet or one specific IP address. So I want to go over some tips on how to solve subnetting questions. One type of question you're likely to come across is, what is the subnet address for a particular IP address? We could use the AND procedure to find the subnet address, but there's an easier method. What we can do is just take all the host bits and change them to zeros. So in this particular question, which subnet does host 192.168.199.199/27 belong? What we need to do is find the octets that contain the host bits. This IP address has a subnet mask of /27, so that means all the host bits are in the fourth octet. So I'm going to take that octet and convert it to binary. The red indicates the host bits, the black are network bits. So the next thing I need to do is change all those host bits to zeros and convert back to decimal. Once you have this decimal number, you can replace it in the IP address and that will be your answer. So the answer for this question is 192.168.199.192. This is the subnet address that this IP belongs to. The next type of question you're likely to come across is finding the broadcast address. To find the broadcast address, what you need to do is change all the host bits to ones. So for this example, what is the broadcast address of the network 172.22.123.64 with a subnet mask of 255.255.255.224. With this subnet mask, I can see all the host bits are in the fourth octet. So I'm going to take the fourth octet and convert it to binary, the red being all of the host bits, then just change all the host bits to 1, convert it back to decimal, and put it in my IP address. So the answer for this example is 172.22.123.95. Again, all I've done was change all the host bits to ones. The next type of question you're likely to come across is to find the first valid IP address in a subnet. To solve this type of questions, all you need to do is change all the host bits to 0 except for the last host bit. The last host bit should be a 1. What is the first valid host on the subnet that the host 172.24.105.247 with a subnet mask of 255.255.252.0 belongs to? What they're saying is you have one particular host on a subnet. They want to find the first usable IP address in that subnet. So the first step that we need to do is to figure out which octets contain host bits. In this case, the last two octets contain host bits. So I'm going to convert those two octets to binary. Once I have them in binary, I'm going to change all my host bits. The red indicates host bits to zeros except for the last bit, which I'll change to a 1. Once I've changed all my host bits, I'm then going to convert both octets back to decimal. Then place them inside my IP address, and that will be my answer, 172.24.104.1. The next type of question you're going to come across is to find the last usable IP address in a subnet. To solve those type of questions, you need to change all the host bits to 1, except for the last bit, which you changed to 0. So for this example, what is the last valid host on the subnet 172.21.108.128/25? I can see by this subnet mask that all my host bits are in the fourth octet. So I'm going to convert the fourth octet into binary. The red indicates host bits. Once I have it in binary, I'm going to change all the host bits to 1, except for the last bit, which I'll change to a 0. Then I'm going to convert that back to decimal. Once I have it in decimal, I'll place it in my IP address, and that will be my answer, 172.21.108.254. In some questions, you'll be asked to find both the first and the last usable in a range. To solve those type of questions, you just need to use tip number 3 and tip number 4. Basically, what you need to do to find the first in the range is change all the host bits to 0, except for the last one, which you changed to a 1. To find the last in the range, you need to change all the host bits to 1 except for the last, which you change to a 0. Then you'll have your answer, and it'll be in a range format. This is the first usable in a range, and that's the last usable in a range. The next type of question you'll come across is to find the last subnet address. The easiest way to do that is to change all the borrowed bits in the original classful address to 1s. So let's take a classful address 172.16.0.0 and create 4 subnets, but list only the last subnet address. To create 4 subnets, we need to borrow 2 bits. The default subnet mask for this address is a /16 because it's a class B. So the new subnet mask will be a /18. The original 16 bits plus our 2 borrowed bits. If we convert that to decimal, it will be 255.255.192.0. So those 2 borrowed bits are going to be in this third octet. So I'm going to take my classful address and write it into binary. The red indicates the host bits. The green indicates the borrowed bits, the borrowed network bits, and the black indicates the original network bits. So all we need to do to find the last subnet is to change the borrowed bits to 1s. So I'm going to change those to 1s, then convert the entire address back to binary, and that will be my last subnet address, 172.16.192.0. The last type of question you'll come across is to find the number of subnets and the number of usable hosts per subnet. We can do that with 2 formulas. 2 to the number of borrowed network bits will find the number of subnets, and 2 to the number of host bits minus 2 to find the number of hosts per subnet. To solve these type of questions, you need to know what classful address this originally was. Because it starts with the 172, we know this was a class B address. A class B address will have a default subnet mask of 255.255.0.0 or in CIDR format /16. After subnetting, our new subnet mask is 255.255.255.224. 8, 16, 24, 27 network bits. After subnetting, we have 27 network bits. Before we subnetted, we started with 16 network bits. So to find the number of borrowed bits, we take our new subnet mask and subtract our default subnet mask. That will give us the number of borrowed bits. Then we can plug that number into our formula. 2 to the 11th equals 2048 subnets. To find the number of hosts, we need to take the total number of bits. It's an IPv4 address, it has 32 bits, and we need to subtract the network bits, both original and borrowed. So if we have 32 total bits, and we subtract the 27 network bits, we end up with 5 host bits. 2 to the 5 equals 32, minus 2 equals 30 hosts per subnet. So our answer is going to be, we're going to create 2048 subnets, and each subnet will have 30 hosts. Okay, that's it for this video. Thank you.